Welcome to MLDS 2021. Super excited to be here. I hope everyone's feeling positive and enthusiastic. Today, this is the topic that we are going to talk on. And our talk is going to revolve around breaking some of the beliefs of machine learning, breaking the reputation of machine learning, why organizations struggle to bring machine learning applications into their everyday analytics, and what is the right way to actually scale on this machine learning glide path. That's what we're going to talk about. And we are hoping that by the time this session ends, all of us feel that the journey to machine learning and its application is actually elementary, my dear ML. So let's start on this simple fun note. Um, let's start with some unconventional definitions of machine learning. Why unconventional? Because we obviously know the conventional ones, the stats and the complex heavy words. So let's break that. Let's hear some of what's top of mind. What have you heard, right? So feel free to drop in any, that are top of mind for you that you relate to in the Q&A box. But these are our favorites. Obviously, when you're fundraising, it's artificial intelligence. When you're hiring, of course, we deploy machine learning. When you're implementing, most probably you're doing a regression. And very honestly, when you're debugging, anything works. But yeah, printing out the data is your best bet. This is one. Of course, there's another which talks of if you're doing it on Python, then it's definitely machine learning. But then if you're presenting it in a jazzy PowerPoint, it must be artificial intelligence. So obviously, all of this is on a lighter note and to be taken with a pinch of salt. But there's some grain of truth to it. In terms of when it comes to simplistic applications, somehow machine learning doesn't cross our mind. Despite the fact that honestly, machine learning is in our everyday life, right? After all, let's go with the definition of machines. They are supposed to make your everyday tasks easier, right? And so by that logic, machine learning should be making your everyday analytical processes simpler. Just like a macro observes tasks and repeat them for you at scale, a machine learning algorithm should be able to observe the data and the decisions taken in the past and be able to replicate that and that outcome at scale. It is exactly with this objective you see machine learning in so many diverse uses in our everyday life, right from navigation to security to personalization. In fact, even those not so pleasant ad breaks that come when we are playing our favorite song. So machine learning is at the core of all of this. So when it is so strong in our everyday life, yet when it comes to when we talk to businesses about what do they feel about machine learning, we hear a different story. It's complicated. It's not my cup of tea. My systems are not compatible with it. Um, Too much maths, too much coding. How do I even know this is adding value? So now suddenly, why this difference? What is giving machine learning this reputation? Ashwin, what do you think is happening?
Yeah, Shanti. So I think there are three major reasons why machine learning has this perception. And we'll start with a very definition at the start, right? So when we hear machine learning, we are exposed to this universe, right? So there is machine learning, right? It's a thing. But then I don't know how many people realize that machine learning is a subpart of AI, right? So there is a whole taxonomy, right? So under AI, you have NLP, robotics, social media listening, and all of these other things. And machine learning is just one branch in that. And under machine learning, further you have three major categories: supervised, unsupervised, and reinforcement learning. And in that, further you have further sub branches, right? So there's tree-based methods in supervised, association rules, regression, neural networks. In unsupervised, you have clustering, similarity algorithms, dimensionality reduction, anomaly detection, and then in reinforcement, you have transfer learning, Q learning, and all that. So there's a huge taxonomy that is there. And people need to realize this, like any other field of study, machine learning is also, part of a larger paradigm of AI, and there is a learning curve to it. There is there is a need to understand and appreciate that it is a broad field of study, and there is breadth and depth involved. So whenever we throw around this, let's do ML, right? We have to understand that there is far more to ML than just usage of that term. And the second is there are some commonly held beliefs and perceptions about ML, right? And we've all heard this in some shape and form. So one thing is just do it. Now just do ML, just do AI. Let's do AI. Let's do ML. We've all heard of this. And there are also combinations. Let's do AI ML, right? So when do you do it is right? Is a common misperception. You can't just do ML. What about it, right? Does the problem require ML? And then the second part is bigger is better, right? Let's do the latest framework. Let's use the latest architecture, the most fanciest algorithm. Let's go big, right? So these are two commonly held beliefs that sort of is daunting to a lot of people. So, but what do we do about this? So, how do we break these misconceptions, Shanti?
So, Ashwin, literally the times I've heard that let's just do ML, let's just apply some AI. The point is, let's really stick to this. Do you even need machine learning? So let's go with that belief one. Machine learning, just do it. In fact, don't just do it. You can always make a choice of where machine learning is needed and where it can add value. Now, how do you make this choice? Three levers to consider. First, it has to be a frequent decisions. If you're going to repeat it again and again, that's when you need to consider machine approach, because obviously we humans cannot keep repeating that. Second, it has to be at scale. The scale we are talking of massive, be it a data scale, be it a decision scale. We are talking of scale. Third, the impact or the breadth of that decision is very wide. Now you're talking a machine learning scenario. So let's look with some examples. What if your business problem requires a very high accurate, very frequent outcomes and a high impactful decision making algorithm? You're definitely looking for a machine learning superstar. And you would be looking in such a scenario mostly something like a deep learning or a reinforcement learning or network modeling, something of that kind of genre. Where would you apply this? Let's look at a scenario like a dynamic pricing for all your products. Now, obviously, this is dynamic. It needs to be real time. It needs to take into account a lot of factors, your competition, market changes, price perception, so many things coming together, but it needs to happen so often and it has to be very accurate. Now you're talking of this machine learning superstar, right? But what if your decisions or your requirement is of frequent outcomes, but not really, the action to be taken? It's rule based. You know that if this happens, this happens. Like, for example, let's say your competitor changes price. Uh, if your competitor changes price and you need to monitor it, and there's a rule. So if my competitor changes by 5%, let's just lead it. Let's go for gun for it. Let's match price, or let me lag it. Let me keep it at 4%. Rules are set. When you do that, then that's when you need a rule-based machine learning. What would work very well could be a supervised decision tree, perhaps. Now let's move away from that scenario. What if you're launching and you're deciding the price strategy for a newly launched product? You don't have data. There are so many things to consider: the market, the landscape, the competitor, the entry barriers, the price perceptions, the product perceptions. How is your product differentiated from a competitor product? So many factors that data cannot do complete justice to. This is when you introduce an expertise approach. Let your experts, your business intuition, your context shake hands with data algorithms and come up with a robust approach. So that's where you may go for some custom modeling, niche modeling, a very high end, maybe a hierarchical market mix modeling or something of that sort. Finally, what if you're looking at a high frequency of low frequency of decisions and low impact? Then let's say you're setting everyday low prices. Now like it is said, everyday low prices, you already know what is to be done. What you need is operationally viable an approach, what is able to give you quick benefits, run it quickly and give you operational efficiency. So this is can be your metric or your framework for making that choice, and getting maximum, extracting maximum value out of machine learning. So machine learning, don't just do it. So that, I think, sums up belief one. What about belief two? Is bigger always better, Ashwin?
No, absolutely not. So bigger is not always better. I think your problem should sort of define what approach you take and not the other way around. So let's sort of look at some examples, right? So we can just probably look at three popular applications, right? If you want to understand affinity between products, if you want to understand what combinations of products go together, and or like an item and item set, what categories go together, how to decide an optimal basket mix. The traditional approach was to use an a priori algorithm, right? So you can tune that using confidence, support, lift, and all of that. And that's still relevant. You can still do it for small applications. However, now with more dimensions being added to the data, especially about a lot of customer data being collected and a lot of behavioral data being collected, a collaborative filtering approach makes more sense, right? Where you can understand, the whole paradigm is that similar customers have similar tastes, right? So going with a collaborative filtering is the sort of natural evolution that you would see to understand affinity between products. When it comes to forecasting, right? Everybody does forecasts, right? But the traditional approach has been to go with a moving average based approach or something like an ARIMA or an ARIMAX or a Holt Winters or any other hybrid approaches that basically give you visibility and predictability. But now with a lot more data points coming in, with the length and breadth of data increasing, you would probably go with a long short-term memory network or some other sophisticated architecture to get higher accuracy. However, I'd like to warn that in these cases, there is a trade-off, right? In a traditional approach, you would have options to tweak some of those forecasts and all of that. But with a more sophisticated algorithm, you might lose out on the explainability factor, right? And then when it comes to classification, right, or the classic logistic regression, which is still relevant and will continue to be relevant, was the sort of go-to model that was used to classify. But now with more data coming in and with different types of data, especially with image classification and stuff like that, a deep learning approach is the natural evolution, right? Because there are constraints to what you can do with the logistic regression. So this is, to summarize all of it, keep it simple but scalable, right? Learn how to kiss, as I say. So this is the sort of natural evolution, and people need to realize that bigger is not always better. Understand what is your problem, understand if the approach makes sense, understand the trade-offs involved, and then proceed. Okay. So that was, yeah, I just sort of sprinted through all of that. That was fast. So Shanti, do you think we should do ML sprints then? Do you think that's the right way to go? That organizations should do like quick sprints of ML? Is that
So
is that the best way for ops to go?
Ashwin, sprints are great for planning your everyday tasks and short-term goals, but for machine learning, no. Um, Remember, machine learning is not a sprint; it's a marathon. You have to build it up to it. You have to keep up the appetite. You have to keep up the stamina, and you have to scale on it over time. Only then can this journey be long lasting and sustainable. Remember, it's about endurance, not speed. Unfortunately, this is where things go off a bit, right? Because what happens is, in this rapid world, organizations tend to, you need rapid decisions, you want everything fast, you want quick ROIs, you need this. So there is this jumping the gun. You want to reach that last leg without going through the journey. But when that happens, remember, the outcome that is generally observed is fatigue. When I'm talking of fatigue, what am I referencing? Data fatigue. Remember, machine learning requires a lot of data. So the data collection, harmonizing, putting it together, it becomes stressful. Second is your infrastructure fatigue, right? Because to run a good, high-end, high scalable machine learning algorithm, you need computing power. So your infrastructure may not be ready for it. Suddenly you're trying to piece it together and your infrastructure starts to feel the strain. Third, time. Everyone wants everything done quickly, but you also want to use the most sophisticated approach. This is a conflicting thing that happens. So you reach neither here nor there. So time fatigue. And the last and most important, according to me, your expertise fatigue, your team. Remember, when you're setting up something on ML, you are talking of all, you're talking of data mining, data collecting, harmonizing, analyzing, research, learning, training, implementation, so many things. Basically, if you look at it in a nutshell, your analytics, your consulting, and your technology coming together. This is a multidisciplinary team that needs to come together. And that's not an easy feat. So when we try to jump the gun and when we try to do it in a sprint and not really run the race, right? What happens is that this journey breaks and it just leads to not very counterproductive outcomes and only adds stress and strain to your system. So please, when you're thinking of machine learning, think marathon, not sprint. But Ashwin, this is where the biggest question comes in. What is a framework? How do we get away from the sprint mindset of machine learning to marathon? What do you think?
Yeah. Absolutely, Shanti. I think we should build endurance and not aim for speed. And I think we can explain this sort of marathon framework through our own experience at Ukam, right? Where we've worked with multiple retailers and large Fortune 500 companies. So maybe we can talk through, some of our applications to illustrate this marathon mindset. Okay, so let's run a marathon, right, with our own experience. And let's run a marathon with text or unstructured data, right? Because this is something that we're all exposed to. And when I say text and unstructured data for the uninitiated, it is basically any data that you cannot visualize in a tabular format, right? Customers' reviews and ratings, website search metadata, or any other site metadata, customer service interactions, and website content as well, right? Which is very important. So we'll talk about how we sort of did a marathon and derived maximum value for it with a large Fortune 500 client of ours, right? So let's sort of lay the foundation, right? So when you have customer feedback data, what is the first thing that you would do with this, right? So you would normally probably read through it and see, how to make sense out of it. What are customers saying? What do customers want? And all of that. But then when that's going into the tens and thousands or even millions, then it's not scalable anymore to do a manual intervention. So let's lay the foundation, right? So do you need ML at this stage? No. What you need is simple text mining. So the situation here is that we wanted to understand what customers were saying about products. There was a lot of website reviews, ratings, and all that, and we wanted to understand why products were being returned in certain categories, right? So what we did first is we did a word cloud, a simple word cloud, a simple term frequency based word cloud, right? We categorized 5-star reviews and 1-star reviews to understand if we can distill out the good and bad, and there's a contrast between them, right? So we used a very elementary application of text mining to do a simple word cloud, and then we were able to see some signals, as you might see here, where customers were talking about fake products and counterfeit products. um, right? So that itself was such an elementary application, but gave us so much value because we are summarizing this text data, and we are quickly able to just get a direction where people are talking about fake products, and we were able to investigate that. But now that is a singular word, right? It's a unigram. But if you want to understand the next level of detail, bigrams, contextual usage of words. We also looked at combination of words or bigrams, and we saw some more references like, hardware was missing, there were missing parts, packages were open, there was like a broken wand, stuff like that, which gave us even more insight into what customers were talking about these particular parts or products, right? And just by doing this, just by this elementary application, we were able to see a 20% reduction in product returns because we were able to tackle the counterfeit products issue, and which particular parts or products were more susceptible to breakages. Um, we were able to, we could realize that customers are calling products fake. We helped them in going after these sellers who are selling some counterfeit products. They were unauthorized sellers on the platform. And this itself gave so much value to them, right? So out of nothing, without any fancy ML usage or anything like that, we were just simply understanding what customers are saying, understanding at least the first level of pain points that customers were facing, right? But then, of course, this is not enough, right? Because once you have a lot more this one, and once you blend in all the different categories or comments from different places, you might have Facebook comments, you might have comments coming in from your customer call center. Of course, you have reviews and ratings and all of that. Uh, then we need an algorithmic approach to make sense out of that. And that is where we wanted to sort of extract, connect, and classify, right? So we wanted to understand customers' complaints in a little more, in a deeper way. So we want to understand contextual usages, what are the pain points, and all of that. So in this case, what we did was we use a topic modeling algorithm. The most popular one is LDA, latent directly allocation, where it is a way of understanding and extracting, or classifying words as topics, right? So this is a representation of the actual output that we got. All of these different areas are the different categories of comments that we were able to classify. And we were able to draw connections between how they were used as well. So for example, the green bubble will talk about, order tracking, shipping, and all of that. Those were mostly, those were topics relating to customer delivery issues. Then things like, you know, uh, complaints about complaints about delivery and all of that, like delayed, received, and all that. Complaints about items being out of stock, damaged, I want refunds, were there in the separate topic. And then on the website itself, when customers were trying to log in and understand, uh, where their items were, they could not track it, right? So they could not update their password. They could not, their account was deactivated. There were some issues, right? And because of this, we were able to understand more nuanced customer issues that we could not probably identify with a simple word cloud. And the impact was that we were able to reduce customer complaints by 30%. We were able to reduce the number of customers calling in, the call inflow into the customer service center. Um, we help them in refining their FAQs on the website to address some of these issues where customers would not have to probably call a call center and get that info. We also identified, like some issues in the tracking API that the third party logistics carriers were providing. And overall, we were able to deliver a better delivery experience to customers just from, like a simple foundational uh, use case along with the topic modeling. So,
Ashwin, this is in fact reminding me that, of another use case. Uh, this same approach, like what you did right now, we started with a unigram and we kind of layered it up with bigrams, then we grouped it and classified it. What if we continue this journey, further? Can I address some more questions? Yes, there
sure.
can. Exactly. So this was one use case, right? So let's see, now we've understood what customers are talking about. Now, what if I want to take this one step further? I want to know what is important to customers in a category. And I want to know what do they like or dislike or they wish for in a category or in the products in the assortment. Because remember, if I answer this question, I can also answer what should be the kind of product interventions I need to do, which products I need to innovate, which products I need to stock, drop, keep. So many decisions can be taken if I solve this problem. So here again, following the same approach, right? Layering, start with the bigrams, unigrams, and then we got the words and we connected them together in a topic modeling format, right? And then we layered that out with a sentiment analysis framework, right? And then, we applied that and we did some granular dictionary based attribute extractions. So what you can see is, if you can see this layered, we took the reviews. This was done on online reviews. We took the reviews, we classified them into topics. The same approach which Ashwin just spoke about, LDA, and we did that. Went one level further and layered a sentiment analysis, what you can see, and we did a competitive analysis. So we knew on these particular topics, where are we better off and where our competitors are better off, so that we can learn and grow. And then we did this, you can see the negative, the pain points of the consumers is where we focus, because remember, product development comes from what is not working for the consumers, right? So we did that. We did dictionary based, dependency graph based approach and got those attributes out. And then we could actually come up with actionable intervention points, recommendations, that what should you be doing about your product quality, about its packaging, about its design, about the marketing. And why this is so interesting is because this was not done for just 1, 2 use cases. We are talking of this in scale. We are talking of giving and identifying such opportunities for 150 plus product groups. And how is the scale looking like? 2 weeks every category. That's 30% faster speed than what was then in the traditional approach. So machine learning actually enabled this for us. And if you see, this did not happen overnight. This did not happen in one go. It happened one step at a time. So layering always is a good way to move along that machine learning glide path, right? But that obviously brings a question that, is that the only way? Do I have to do it sequentially? Do I have to just take step 1 and then 2 and 3? No, there is other ways to do it. Smash it up, ensemble it. So ensemble bringing multiple things together, right? You want to try, multiple approaches. You want to do them together and bring the outcomes in together. So there are so many ways to do it, right? So in this situation, we used an ensemble approach. Now, what was the situation here? We are talking of a marketplace. Marketplace is basically, marketplace retailer is where sellers can sell, the different sellers can sell the same product. So here we, the marketplace retailer wanted to do a competitive assortment analysis. Now remember, whenever you need to do an assortment analysis, you need unique products to be matched against your competitor and do, the strategies. Now, when it's a marketplace, you have the different sellers selling the same product, but because there's no naming convention, the products are all named differently. So now we are talking of millions of listings. How do I even bring this down to a logical set to my product level and then do this competitive analysis, right? This is the problem. Now, this is where we realize that one technique is not going to cut it, because obviously we're talking of product listings. They have so many rules, they have so many naming conventions, so many, non-standard ways of doing this. So what we did was we started with our text mining. Let's extract out the attributes. Then what we did was let's apply association rules. So if the MPN is the same, possibly they belong to the same group, so do that. Okay, in parallel, we started to do a clustering approach. Let's put some parameters, let's put some price, the vectors, the attributes, and cluster. So if products have similar attributes, they might be in the same product group. So we applied a clustering. Now, when we did the clustering, we realized that, oh, products and accessories are coming together because they also have the same attributes. So now we did a cluster profiling where we added price as a parameter, because your accessories are going to cost lower than your actual product. So we use price as a, as a mixer in that. And then we did, we also looked at some rule-based associations, like let's do some rule-based grouping. All of these came together. They were done, in different parts, in pieces, in formats. And the outcomes from these is what helped us get to that compressed listings. And we were able to group similar listings in a very short period of time, just using machine power. And we were able to compress 60% of the listings. And this was an ensemble approach. So what we're talking of is that, I hope we are getting the flavor. We are not jumping to the last stage. I'm not jumping into a clustering and into a, kind of any cognitive or computing or supervised algorithm. What we're doing is we're building onto the journey. We are starting with one element, layering another element on top of that or in parallel. And we are doing this and we are building onto this journey. So it's, remember that note, it is not a sprint. It's a marathon. You have to endure. You have to build up to it. So this is what, is the ensemble world all about. So what's next? How do we go about now?
Okay, I think we are midway through the marathon, Shanti. But I think there's one thing that you need to really sustain through a marathon, right? And endurance, right? We endured through this entire journey. But then what about stamina? Where does stamina come into play here? So the stamina in this case, a key component is technology, right? So an unwritten rule is that you must evolve your tech and infra stack along with your ML stack as well, right? You cannot have just standalone ML models if you want to, if you have high frequency decisions to be made with high impact. You also need to have a strong technology stack. You need to have a strong data engineering capability to maximize the benefit and the impact, right? And so maybe we can talk about that one use case where we also used technology very effectively along with sophisticated ML models after we have gone through this sort of endurance journey, after we've gone through this marathon, right? So let's talk about a use case where a lot of people may have faced this, but they don't know actually what's happening under the hood, right? Let's talk about search, right? Everybody has used search on a website, right? Everybody has
Ashwin,
gone to a website, search for a particular item,
Ashwin,
and then have found.
just 1 minute. Before you head on to the use case, there is 10 minutes left for the session, and there are a lot of questions as well at the on the Q&A tab. So whenever you guys are ready.
Sure, sure. Almost there. We're almost at the finish line of the marathon. Don't
Sure.
worry, we'll be there. Well, so let's talk about search, right? So a typical search flow is that you have a particular search term that you will put in on the website. You'll retrieve that through search engine optimization. There are some results that show up based on relevance. And then there is a sorting and ranking to ensure that you find what you're looking for. But then a lot happens under the hood between these two stages, right? So in this particular use case, what we did was we first looked at all of the site terms that are coming in, like all the search terms that are coming in on the website. We looked at a Pareto distribution, right? Because not all search terms are important. We need to figure out the 80-20 split. 20% of the search terms might result in 80% of the volume and also the conversion, right? So first, after we had the search term, we figured out the relative importance of whether it is a head, tail, a head, mid, or a tail, right? So of course, we don't want to put in a lot of effort on the long tail. We want to focus on the head and the mid. Once we determined that, we had an attribution model to extract relevant attributes, the product type and the brand of the company name from that. Once we did that, we put it through an ensemble model of, we had to vectorize it because this is addressing a big issue of synonyms, right? So when I search for, say, glue, I might have search results that are saying adhesive, but they mean the same thing. Our brains have evolved over millions of years to quickly understand the association, but for a machine, we'll have to figure that out, and we'll have to make it into ones and zeros, right? So once we put this ensemble model of converting a word into a vector and then figuring out the distance between the vectors to understand the synonyms, we could then have a clear feature-rich search query. Once we got that feature-rich search query, that refined feature-rich search query was then used to figure out what are the relevance of the search results, right? Because all of the search results that would be coming up, we measured the distance between this new vectorized search query and all of the results, and then the ranking and sorting happened. So there were much more relevant search queries that were coming up, right? And just by how this was set up, this was built to improve over time as well, right? So as and when I had more synonyms coming in, and as I could improve that synonym identification, my search results also got better. Now, one thing we need to understand very clearly in this is, so all of this sounds good, right? But how do we actually measure, right? And that is one thing that we were very careful about. We wanted to have a proper tracking and measurement framework to go along with this, right? So not only did we just do all of this, we also identified the key metrics that would tell us that the system is working as intended. It would tell us where we should focus on, whether the synonyms are working fine, whether there were certain search terms that were not being addressed, and all of that. And some of the metrics that we used, like the number of search queries, conversion, new entries, and all of that, helped us in refining this setup better, right? One thing I'd want the audience to take away from this is always have a North Star metric. Always have one or two major metrics that you're going to use as a success criteria that you want to move the needle on. In this case, our North Star metric was conversion, and we were able to improve the conversion by 27% because of this entire setup, right? So that is so this is an illustration of how technology also needs to evolve in order for you to derive maximum value out of ML. So is that it? I don't think so, right? There's still more. What's next? We're already seeing some more amazing use cases, right? We're seeing robots writing articles, and say there was a popular article that came out which was written by GPT-3. We are seeing that algorithms can actually create images from text. That is a DALL-E by OpenAI. And the world is also moving towards auto insights and no code ML, right? For those of you who think this is all daunting, there's code heavy applications and all of that. The future of code is no code, and the future of ML is no code ML, right? So there's so much to do. There's so much happening, so little time and so little coffee. We're living in exciting times, lots of interesting things that are happening. So Shayanti, what do you think? What should the audience take away from this? Any final thoughts?
Ashwin, I do definitely have a lot of takeaways, and I hope the audience can resonate with those. So I think first, like I kept saying, machine learning Don't just do it. Be choiceful. Choose the right technique based on those three levers I spoke about: scale, frequency, and impact. All problems don't need high-end solutioning. Bigger is not always better. Think elementary. Build it up, layer it up. Think marathon, not sprint, because otherwise you're going to go into the fatigue stage. We spoke about that. Small improvements along the journey. Keep up that endurance, keep up the stamina, and keep up the appetite. That's how you can scale on that glide path. In this journey, technology is going to be your life partner. So get comfortable with technology. And finally, it's not just enough to just, kind of just deploy machine learning. You also want to measure it. You want to be able to showcase that it's adding value. You want to be able to capture its impact. So always keep your eye open for a metric. What is going to be that North Star metric that you're going to track, and you're going to attribute it to the machine learning contribution to your process. So these are the key takeaways from the session. I hope all of us can resonate with that. And also I want to leave us, because together we are here, right? We are the machine learners and developers. So I think as a community, it is also our responsibility to give machine learning its due credit, right? It is actually here to help make our analytics processes simpler. We need to show the value it's bringing to the table. And we need to realize that they are machine learning should be, or technology, these should be partners to our business inputs, not competitors. It's a two to tango, right? So let's bring these together. And the second and most importantly, like our topic said, it's elementary, my dear ML. Let's simplify, let's make machine learning world a better place for both you and me. And by simplifying the usage, its application, its understanding, and its access. So I think as a community, we owe this to the world out there. So that was from us. That's thank you for being such a great audience. Thanks, Ashwin. We are open for questions. I see there are many, and there are some lovely comments. I think thank you for all the encouragement and the support throughout this journey, throughout the marathon, like we spoke of. But yeah, open for question answers. I think I've addressed some of them. Ashwin, do you want to pick up some? Maybe Ashwin, you want to answer? I can quickly talk to you about some of them which have come by. Starting with, I think, metrics. I think one of the questions from Ashim is, how should we identify the right business metrics to show impact of the solution? I'm seeing some great metrics on your slide. How did you identify these?
Okay, so I can take a shot at that. It depends on what problem you're trying to solve, right? For example, let's go with one of the use cases that we spoke. So obviously search is something that we spoke about, where the eventual end goal is, customer experience and hence conversion, right? Is my search facilitating a better conversion, right? So we need to understand what is the end state, what is the goal we're trying to achieve, and what are the metrics that sort of define that end state. Maybe if you can ask a specific question, then we can probably talk about what is the right metric. It completely depends on your use case. I don't think there's like a one shot answer. For example, let's take, say, customer segmentation, right, where you want to identify customer segments. If your goal is to send them personalized emails and market to them better, then you can have your North Star metric of revenue, just revenue, like I'm doing all of these customer segments, but how much of an incremental revenue am I getting from that because of better engagement? So those can be this one, unless there's a specific question about a use case and what is the right metric. Just figure out what is your end goal and then work backwards to define what are the metrics that should go with it.
So Ashwin, I think we are out of time, so I'm not able to take all these questions, but you can always connect with us. Shayanti, Ashwin, you'll be able to connect with us over the lounge or over other things. But some of these questions are, how much time do you take to build an end-to-end ML approach?
Marathon, not sprint, remember.
Yeah.
Right. So do not put a time frame on ML is one of the things that we've learned, right? Of course, you need to sort of layer on to it. You need to first figure out whether ML is required or not, right? Do not sort of use ML like a hammer for every problem that's a nail. Figure out what is the value you want to drive, what is the problem you're trying to solve, and then your existing rule-based or other methods, if it's not giving you that value, then decide what is the right metrics. And of course, mix and match, try different things, ensemble it, whatever is moving your your key metric, whatever is addressing your North Star metric, go with that approach.
Okay.
I think I think we are
Shanti,
out
you
of
want to add
time.
you want to add something to this? Okay. So it was a great session. I think you guys can read the comments on the chat. People are blown away with the presentation and the way you guys have explained the concepts and the misconceptions, attached to machine learning. It was a great session. Thank you again for doing this.